Hey everyone, today we're going to discuss about the domain and range of a rational function. Now, since we've learned how to get the asymptotes and how to graph a rational function, this time we're going to get the domain and the range. Now, the clearest way to determine the domain and range of a rational function is by graphing it, since we can visualize it using a Cartesian plane. We can easily see which values of x are being used and which are not. However, it's quite impractical, and there are several things that we can apply to make our solving for domain and range a little bit easier. Now, it's much easier to determine the domain and range of a rational function if there are no oblique asymptotes. If there are oblique asymptotes, then our way in solving for the domain and range can be a little bit harder. So let's have an example without any oblique asymptotes first. Let's have f of x is equal to 2 over x plus 5. Now, to solve for this, what we just have to do is we just have to obtain the vertical and horizontal asymptotes. And we will exclude, take note, exclude those values in our domain and range. Since remember that the asymptotes indicate the part where the graph approaches that value, but it never really reaches that value. So those values are not included. It just gets really closer and closer to that part, but it never really reaches that. So let's solve for the vertical asymptote. So this is x plus 5 equals 0, or x equals negative 5. Therefore, the vertical asymptote is x equals negative 5. For the horizontal asymptote, the degree of the numerator is 0, since there's no variable, and the degree of the denominator is 1, since there's only x. Since we have this case, we have n is less than m. And since n is less than m, automatically we can say that y equals 0 is a horizontal asymptote. So we are not going to exclude x equals negative 5 and y equals 0. Now, for the rest of the values, they are included. As long, but remember, this rule applies if there are no no oblique asymptotes. We can see here that there's no oblique asymptotes since it doesn't follow n equals m plus 1. Since n is 0 and m is 1, there's no oblique asymptotes here. Now, for the domain, what we're just going to write here is all real numbers except x equals negative 5. This means that for the domain, we used all real numbers from negative infinity up to positive infinity, but we are going to exclude negative 5 as part of the domain since it's an asymptote. For the range, it's the same thing. All real numbers except y equals 0. Since for the range, it uses all values of y except for y equals 0. Okay, let's confirm that by actually graphing the example that we just had. So we have f of x is equal to 2 over x plus 5. I'll leave it up to you on how to graph, okay? Since we just covered it in the previous video. Now, if we observe here in our graph here, it goes towards to the right and towards to the left. So it uses all the values of x's from negative infinity up to positive infinity, except when x is equal to negative 5, since it is an asymptote. So it uses all real numbers except when x equals negative 5. And in the same manner, for the range, the graph moves upward and downward except when the value of y is 0, since it approaches that part, but it's not really included. So all real numbers except x equals -5 for the domain, and for the range, all real numbers except y equals 0. Now, if the graph has an oblique asymptote, it gets a little bit harder, since you have to accommodate what the oblique asymptote does to the graph. So in order for us to determine a domain and range of a function with an oblique asymptote, we have to actually graph it. So I'll leave it up to you on how to graph this function. Let's just proceed on the graph itself and focus on the discussion of the domain and range. So this is the graph of f of x is equal to x squared all over x plus 1. Now for the domain, we can see here that the graph moves towards downward to the left and upwards to the right. So we can safely say here that the value of x moves towards the -infinity to the left and +infinity to the right, except when x equals -1, since that is its vertical asymptote. So for the domain, we can write here that all real numbers except x equals -1. That's its exception. Now for the range, we have to accommodate what does the oblique asymptote does. Take note that there's just more than one value which are excluded in the range rather. We can see here that it approaches the +infinity and the -infinity at these points. However, there's an exclusion of this space here. So we are not going to include this space here. I'll label it for you. This part here, this is not included in the range from 0 to -4, because that's what the oblique asymptote does. And it's really difficult to visualize that without the graph. So for the range, what we're going to write here is that the range is from -infinity up to -4. And we know that this is true because of the graph. -infinity up to -4, including -4, union. Then from -4, it got cut off and continued again at 0, going to +infinity. So this is our range here. So that's all for the domain and range of a rational function. I hope you learned a lot today, and see you guys in the next video.